Rotting oranges. You are given an n by n grid where each cell can have one of three values. 0 representing an empty cell. I'm just taking a look at this parameter signature grid int. Okay. 0 representing an empty cell, 1 representing a fresh orange, or 2 representing a rotten orange. Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. Four directionally adjacent to a rotten orange becomes rotten orange. What is 4 directionally adjacent? 4 directionally adjacent. Oh my god. Adjacent mean? I'm assuming like there's like. Let me just pull up my whiteboard. I'm assuming like if we have. If we have an orange, let's say, in here, and then we have 4 rotten oranges, 1, 2, 3, 4, then this one will become rotten as well. That's what I think it means. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. So I do see an example over here. But I'm going to just copy paste this over here. Try thinking of an example of my own, and if I struggle more than like 5 or 10 minutes, then I'm gonna look at the example that they gave. Alright, so immediately I'm thinking, so return the minimum number of minutes. Every minute. So we have to keep track of time. And return the minimum number of minutes that must elapse until no cells have a fresh orange. If this is impossible, return -1. Okay, well, first of all, 4 directionally adjacent, I have to confirm what this means, right? And I kind of drew a picture. I think that's what it means. I may be wrong. I'm actually going to confirm that. Because rotting only happens 4 directionally. Hold on. Oh, it doesn't have to be all 4 corners? That is directionally 4, that is 4 directionally adjacent. Okay, and then let's see this. Two, 1, 1, 0, 1, 1, 1, 0, 1. -1. The orange in the bottom left corner, and 1 means fresh orange, is never rotten because rotting only happens 4 adjacently. So how can I, is there like a, there's not even like a black or something color that I can use. Okay, whatever, it's fine. So in this bottom corner, there's an orange, bottom left. And let's see. 1, 0, there's no orange, right? 0 means an empty cell. And to the right, there's no orange as well. And in the middle, there is an orange. Does this count? Or does just one, like up, left, up, right, left, down? I'm assuming those are the only directions. Since there are already no fresh oranges at minute 0, the answer is just 0. Interesting. Alright, so I've confirmed the definition of for adjacent. I've kind of already looked at the examples, but might as well just like look at my own. So we have this example, and I guess like, so can our grid be empty is like the first thing that comes to mind as a clarifying question. And I guess what I want is something like this, 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 and then this. Just a simple example here. So at time 0, this is the situation. At time 1, both of these can turn into rotten. And then time 2, this one turns rotten. So it takes 2 minutes until no cell has a fresh orange. Why does it say minimum? I guess like they don't want us to return like 3, 4, 5, 6, like any number bigger than 2, just exactly 2. So, I guess the restriction on empty cells, fresh oranges, or rotten oranges are within the size of the matrix, or the size of this grid. And they represent in 0, 1, or 2. Those are the 3 integers that can exist in our grid. I don't think no other integer should exist. It doesn't have to be like a square, it can be any sort of grid. No type of sorting, like is there like a dichotomy? Like there's not really much. So there's one situation where they're right beside each other. There's one situation where it's slowly after like T minutes it gets to everything. There's a situation where it's just impossible to get there. A situation that if it's impossible, return -1. Yeah, no other really questions, to be honest. Like those were the questions I had. Let's see what the constraints are. Grid length, grid eye length. So minimum is 1 for both sides, and then it can either be 0, 1, or 2. Yeah, okay, cool. Let's just take a look at examples here, just to ensure I have my understanding correctly. So we have 1x here, yep, and then it spreads out adjacently, bam, bam. Then spreads out adjacently, bam, bam. Spreads out adjacently, bam, and then bam. Cool. I love when they provide visuals. That's amazing. The orange in the bottom left corner row has never rotten because rotting only happens 4 directionally. So we have 1, 2 here. The 2 spreads to this one, doesn't spread down. It spreads to this one, and it spreads to the middle one. It spreads to this middle one down here, and it spreads to this one down here, but it doesn't spread to this one because it's surrounded by a 0 here on the up, and a 0 here, and a 0 on top of it, and a 0 to the right of it. Like it's over here, and over here on both of these sides there's nothing, an empty cell. There's a rotten orange here, but it doesn't move diagonally, just up, down, left, and right. And then since there are already no fresh oranges at minute 0, the answer is just 0. Okay, cool. Now we're at 10 minutes. Let's move forward with like thinking about a solution. Still not fast enough with the examples. Again, five minutes is what I should be aiming for, but it's okay. Let's keep going. So whenever, like, what are we doing when we go through this like algorithm? What are we doing? Where first of all, we're trying to confirm if there are any fresh oranges to begin with, because if there isn't, then we can just return 0, right? Returning -1 at the beginning, is that possible? I mean, we can do like a check to see if there's any fresh oranges that don't have a rotten orange in any 4 directions, and then that way there's no way for a fresh orange to become rotten. Does it become rotten after a certain time? No, just this rule. And then another thing we're doing is whenever we reach a rotten orange, we've confirmed maybe we don't have to confirm that there's any fresh oranges, but we've come to a rotten orange, and then we have to check all 4 directions and move forward in any of those directions. For me, that sounds like a path, right? And I'm thinking like this is like a graph problem, just from that observation, and like using a depth first search or maybe a breadth. Maybe a breadth first search could work as well. Any graph algorithm to go through all of the rotten oranges in this graph and try to spread it as far as you can. Yeah. So, a few things I'm noticing. Minimum grid length 1, just writing that down for convenience. Whenever fresh orange, you can do a check on all 4 sides to see if there is a rotten orange. Otherwise, return -1. If there are no fresh oranges, then we can immediately return zero, right? That's because all the oranges are already rotten, so there's no cell with fresh orange. And I guess another thing, so I was saying that for search before, right? Going as deep as possible, but like the thing is we have to also keep track of time. And there's a potential of there being like multiple oranges. Like, I mean, a simple example is like if all of this is empty, but there's like a rotten orange here, right? And like a few fresh oranges there, right? There's basically like two different things we have to kind of keep track of. And we have to keep track of the time too. So like it goes here, it goes here, and same thing here. It goes here and goes here, and then we iterate time to 1, and then it goes up to here on time 2. Right? And go through all rotten oranges and increment in one of 4 directions. If possible. So and I guess we're adjusting the grid itself in this case, adjusting the grid in place. Is that okay that we're doing that? Like adjusting the values in the parameter? I'll just make a note of that. That's a question for an interviewer. Now, adjusting the grid in place and keeping track of time. Could be multiple groups of oranges can be scattered. Right? So this like algorithm, so first of all we have to go through all of the elements in the grid, n by n, and then we have to iterate through it by t. Right? T being the minimum number of minutes. And then space complexity, I guess if we're doing that for search, there's like the recursion space complexity to consider. And for a breadth first search, is there anything that we need to keep track of? I guess a queue? How would you do this in a breadth first search algorithm? We would iterate in one direction at one level. Well, I mean, hold on, how would we do this in depth first search? Because we have to go as deep as possible in depth first search. And the same thing with breadth first search. We have to, like, we start at one node, we go in one direction, and then we have to stop. So it's not really, like, are we really doing, like, breadth first search and depth first search here? Are we really looking for a path? Because the path is being rerun on every minute. Yeah. Or another thing we can do is just keep track of the maximum time. Right? Do breadth first search or depth first search and see how long this takes. If there's a different group, just like measure that time and then pick the maximum of these. Right? A bit confusing with the word minimum here, but basically, like, you can't, you need all the oranges to be rotten, right? So that's why you need the maximum time here to get the minimum overall time that elapses until no soul has fresh orange. And then that way we can just make this a matter of n by n by going through. I think it's a bit more than n by n. And I struggle with this, with finding the time complexity of this, because so now we have to look at the vertices plus edges, and there's multiple of these potentially. Yeah. Okay. I gotta work on this. It's time space complexity. Okay. So I got something to work with, so I'm gonna start working on an algorithm. or start working on the code. Hopefully this is space and time complexity are okay. If not, we can, you know, again, speak with the interviewer, see if we can optimize, see which direction you want to move in with that. Now, assuming that everything is all good, you know, this is good, I'm gonna start coding. Let's say let's do a depth first search approach. Let's try that. So we want to go through all the different elements, right? We want to go through for row and 0, 0 for dot count, and for C, 0, 0. At 0 dot count, we can guarantee that there's one element in the grid, so we can do this. If grid RC is equal to 0, then we can just continue. Else if grid RC is equal to what? Then let's do a check. We'll do like directions, and we'll do in 4 directions. So 1, and then after doing this, we'll do for can I do this? I don't know if I can. Let me just do this simple way, even though it's kind of ugly to write. Let dr is equal to direction 0, let dc is equal to direction 1. If direction if r plus dr update row r plus dr and updated column plus dc. If updated row is greater than or equal to 0, updated row is less than, let me just write up here, let rows is equal to grid.count. Let columns is 0. Less than rows, and updated column greater than or equal to 0, updated column less than or equal to calls, and grid updated row, updated column is equal to 2. Then we know we can do like like, so var is impossible is equal to false. Is impossible is equal to true. Or let me do true first, and then let's change it to false here. And then after this is over, we can do if is impossible, return -1, and break. We can just continue from here, right? Because like we don't want to continue checking this for this fresh orange. We want to just move on to the rotten orange. Okay, so now this is the real one. Yeah. So basically the same code as before, to be honest. What are we trying to return? The minutes, right? So let var, let me just var minutes 0, and over here return minutes. So we also know that if there are no rotten or fresh oranges, if there are no fresh oranges, then we can return minutes at 0. Should I do a check for that, or should I just like continue? Well, that's just like worst case scenario, right? So yeah, it's fine. Going through all the elements in the grid, checking all 4 directions. And after checking all 4 directions, recursing as much as we can. This is like its own depth first search really approach. So if grid, like a DFS node really approach, and then let me just write this DFS right here. DFS node. Node being R and C. Okay. So we're at this point. Time, and then we want the maximum of minutes or time. And if it's not possible, then it'll just stop at 0. So var times 0. Again, we're doing the same kind of technique. var directions. And then we have if any of these are 1, that's when it matters. Because then we want to do DFS on updated row and updated column. And time plus equals 1. How do I, so I know I get back a time from this. So whatever time I get back from the first search, kind of the same thing. If it's impossible, then we want to break. If it's impossible, then we want to move forward. Hold on, I'm getting confused with this recursion call and determining where the base case is. So when do we want this to stop? If all of these directions are false, so it reaches like an impossible state, we want to return something. Return time plus equals 1. Let's not think about this other function, okay? It's fine. I didn't put a closing bracket there, and then return 0, return time. It will be 0 if there are no fresh oranges around it. Yeah, I think that's good. Should I just put the variable inside here and just put this as 0? Maybe. Honestly, I think that might just be better. Just put var there. So eventually we'll reach a case when like it's just not possible to keep going. Right? And it's just gonna have to return 0. That's the base case. And then when it returns 0, then we come here, return 0, and then we have a time plus equals 1. Right? And then time plus equals 1. And then time plus equals 1. Hold on. But here we didn't complete all the 4 directions. Right? So we want to return when all 4 directions have been completed. Right now we just went like up. Sorry about that. Okay, we're at 35 minutes. Technically I should be stopping my interview now. I feel like I'm really close though. I just want to reason out. So after this completes, or after this completes, okay, it checks all 4 directions. Increments time when needed. It should return time plus equals 1. So using a strategy over here, if it's impossible. Var no fresh oranges. True. False. Right. If no fresh oranges is true, then it makes sense to return 0. Else, you would return time plus equals 1. And then we'll have to move time back up here. Time plus equals. Does that make sense? No, it does not, because why are we appending the time for each of the 4 cases? Because no matter if we go up, down, left, or right, time will just be 1 for each of those directions. But for the depth first search, yes, we do need to add. Let's see, how many syntax errors do I get? Okay, compiler, I wrote grind somewhere. Should be grid. Okay. Ideally, I want to run through this, like through a test case. What was wrong with this? Oh, updated row. Updated row, updated column, updated dated column. Time plus DFS. So it doesn't have any return time right now, we'll just make it explicit. And then over here, did I make the same mistake? I did. Updated. Okay. Got an error. So I have an infinite loop somewhere, so my depth first search is not correct. So the way I'm doing this is for each iteration, I want to know how deep it can go. And then I basically want the maximum from all of these depth first search calls in all 4 directions. So let's say in up we have 1, and down we have a 2, and left we have a 1, and then right we have a 4. Right, we want to choose the 4 as our time. You get what I mean? How do I get this behavior? Okay, so I've returned 0, I've returned 1. And then time for each 4 directions. Yeah, this is... I like this way of putting it. I'm also considering whether or not this is actually correct. I know the return 0 is definitely correct, right? Because if none of this is false, then there's no way for there's no way for the red and oranges to spread. And so you gotta return 0. And then time plus equals 1, maybe I should just be returning 1 instead. Pending time in all 4 directions. That's not right. What if I do time? Time is equal to maximum of time versus DFS. Well, there's a runtime error. Probably messing up somewhere. Okay. Good enough. Good enough attempt. After, I think what I'm missing is actually running through this through an example. That would probably help with debugging. And then after that, reviewing, optimizing, probably optimizing the fact that I'm using this 2 times now. I did a lot of edge if and else checks as well. I don't know if that was the right move. So that's the optimization, revision, kind of phase, any other feedback, anywhere else I can improve on. Those would be the next steps. But decent attempt. I think decent attempt. Good job.